Uh, Question number 10, part A from exercise 4C D2 7th edition. We can observe that 4 times x minus 1 whole squared minus 81 times x plus 1 whole squared. If you see, this 4 is a perfect square of 2. Similarly, the coefficient of the second term, which is 81, it is a perfect square of 9. So we can write them down like 2 square and then x minus 1 whole squared. Now, since both of these uh, numbers or factors which are written in the form of a product have got squares on them, so we can combine this square to make it 2 times x minus 1 whole squared. Same goes with the second term. 81 is a square of 9. So let me write it down 9 whole squared, and then x plus 1 whole squared would remain intact. Now I can combine 9 squared and x plus 1 whole squared to be 9 times x plus 1 whole squared. And in between there is a negative sign. Okay, then it is going to be the application of the third identity, a squared minus b squared equals to a plus b times a minus b. So in this case now, this is the first term a, that is 2 times x minus a. So since I am having a squared minus b squared format, so I will write it down as a plus b times a minus b. A being 2 times x minus a and b being 9 times x plus 1. So let me write it down as a plus b times a minus b. That means I mean to write it down as 2 times x minus 1 and plus 9 times x plus 1. So I have applied this a plus b. Now I'm going to write it down a minus b. That means a is the same 2 times x minus 1, and now in between I need to use the negative sign and then 9 times x plus 1 once again. Now I hope I have made myself more clearer. Okay, now it is just the matter of simplification. So I can simplify them to be 2x minus 2 plus 9x plus 9. Then 2x minus 2 minus 9x minus 9. So that I can have the simplification of the like terms. 2x plus 9x, that will give me 11x, and then minus 2 plus 9, that is plus 7. Similarly, 2x minus 9x is negative 7x, and then negative 2 and negative 9 is negative 11. What we can do is that we can take negative sign common from these two terms. So we can have it as finally negative sign taken common, then 11x plus 7 times 7x plus 11. So that's the complete factorization of the required part. Now I'm gonna solve part B. 16x squared plus 8x plus 1 minus 9y squared. Okay, what we need to observe is that these three terms uh, look like the three terms of a plus b whole squared, like a squared plus 2ab plus b squared, which can be written as a plus b whole squared, but at a later stage. One observation. Second observation is that we have got a different variable in this term. In this term, the variable is y, and in these terms, the variable was x. So that is an indication that we can simplify them a bit separately. So what we can do is that we can combine these three terms, and we can see that since the first term 16x squared is a perfect square of 4x, yes, the last term in that combination is 1, that is a perfect square of 1, okay, and in between now 8x. Now let me check it out whether I can write it down in this format or not. 2, okay, then a is the first term, 4x, then b in this case is 1. Okay, let me check it out. What do I get? 2 fours are 8, 8x times 1, 8x. Yes, I get the middle term, and this is this term, and this is this term. So we have written these three terms in this format, a square plus 2ab plus b square. So now that is why we can write it down as a plus b whole squared, a being 4x and b being 1. So let me write it down as a plus b whole squared. That means it can be written as 4x plus 1 whole squared. Okay. And now what about the next variable term? So that has to be kept going alongside. Okay. Now, since these three terms have been written in the form of a plus b whole squared, the pattern suggests that there is a negative sign in between, and I can write it down the next term as well. So it can be written as negative 3y whole squared. 9y squared has been written as square of 3y. So now I've got a square minus b square format, which can be factorized to a plus b times a minus b. So in this case, the a, that means the first term is completely 4x plus 1, and the second term is going to be 3y, which is represented by b. So now I can write it down as 4x plus 1 plus 3y, and then 4x plus 1 minus 3y. I have applied this identity, third identity, a plus b times a minus b, that equals a squared minus b squared. So now just the simplification is required. Mm, What's the simplification that we can do? Nothing that much, which is more necessary, but I can just do it. 3x, 4x plus 3y plus 1, and then 4x minus 3y plus 1. What I've done, I've just combined the variables together, variable terms together, and separated the constant, which is 1 in both cases. So nothing that much simplification in this step. This could be the answer as well as this could be the answer. Now it's part C. 4x squared minus y squared plus 4y minus 4. We need to see that In this case, y squared 4y, these are the two terms that contain y. So that is an indication that when we would be applying the identity a squared 2ab b squared, whether with a plus sign or a negative, that is to be decided later on. But we need to observe that it will be applied on the variable y, because y squared and 4y terms are there. This could resemble this and this could resemble this. So that means 4x squared term is going to be kept separate, or it should be left solitarily. So this is what we are going to do now. 4x squared, it can be written as square of 2x. Then we can take negative sign common from these three terms to make the first term y square to be positive term. As in both the identities, if you remember, a plus b whole squared or a minus b whole squared, in both of the cases, the first term a square has to be a positive term. So that's why I want to take this negative sign common from the three terms. So negative sign common, then it would be negative 4y and plus 4, because when we have taken this negative sign common, inside the brackets, the signs are going to change. So now in this case, again, I would be seeing that this can be written as square of y. This 4 can be written as square of 2. Then in between this negative 4y, this can be written as 2 times the first term, which is y, times the second term, which is 2. So when you just multiply them, 2y times 2, that will give you this 4y. So yes, we can write it down like this. So it will give me now 2x whole squared minus y minus 2 whole squared. Now that means it was a minus b that was to be used in this case, a squared minus 2ab plus b squared. So now we can apply the identity a squared minus b squared, which is a plus b times a minus b, and a being 2x, this is a, and then which is the second term b squared. So in this case, b is going to be y minus 2. So that's why we can write it down using this identity to be a plus b times a minus b. So now let's replace the values, if you can just understand it like that. So for a, I have got to replace 2x, and for b, I've got to replace y minus 2. So in between, I need to have a plus sign, then 2x and y minus 2. This time I need to have a negative sign in between, so that a plus b times a minus b can be completed. And now finally, I just need to simplify them if I can. 2x plus y and plus and negative 2, that is negative 2. And in this case, 2x, when you open the bracket, it will be negative y, and then negative times negative 2, that is going to be positive 2. So that's the complete factorization of this part. Now it's part D, which is 13x squared plus 26xy plus 13y squared minus 13. Let me take 13 common, then x squared plus 2xy plus 1y squared minus 1. Okay. Now I can apply that identity. 13 times x squared plus 2xy plus y squared, and for 1 minus 1, I can write it down as 1 squared, so that we can do it in a way. 13 times, this is the complete identity, x plus y whole squared, and this 1 is already in the squared form, so that is an indication that we can apply a squared minus b squared, which is a plus b times a minus b. So let's take that 13 common, and let me write down x plus y plus 1, and then x plus y minus 1. I've changed the sign just to indicate that it is just the application of this identity. And now it's, sorry, I just changed the color to make it more clear. So x plus y plus 1 times x plus y minus 1. That's it. That's the complete factorization of this part.